So now we're going to work on two examples of force that work on the calculation aspect rather than the drawing aspect of forces. So example number 3 here says, determine the force acting on a 5.46 kilogram object if it accelerated at 17 meters per second squared. So here what the question is asking for here is we're looking at force. And this one here is just a general type of force question. So we're going to use the equation. Force is equal to your mass times your acceleration. So in this question here, we're given that the object is 5.46 kilograms. This is our mass. And here we're given the acceleration is 17 meters per second squared. Notice how in this case here, we're not working with a vector value for acceleration. So actually in our answer for force, we can actually just leave it as a scalar quantity as well. So let's plug this into our equation. So we have our force is equal to our mass, which is 5.46 kilograms, times our acceleration, which is 17. When you plug that into your calculator, you should find that your answer is 92.82. And if you guys remember, we have to keep track of sig figs as we're going through this. So with our mass here, we're given 3 sig figs. Our acceleration is 2. So our final answer has to have the least amount of sig figs here, which is 2 as well. Meaning our answer for force is going to be 93. And if you guys remember from the previous video, our units for force are newtons or the kilograms times meters per second squared. I would accept either or. It's just based on your preference. So then just to finalize this question, we need to write each sentence. So the force acting on the object is 93 newtons. So just to repeat why we don't need a direction in this case, it's just because our acceleration, we weren't given a direction. So in this case here, we can assume that our force won't have a direction as well. Moving on to example number 4 here. This one here is actually going to be quite a bit more complicated question, just because now we're going to be working with an angled sort of force. So if this rings any bells to what we did in Unit 1, we're going to have quite a few steps here to try and figure out that process. So a person is pushing a 49 kilogram box so that the applied force is 950 newtons, is at an angle as shown in the diagram. The coefficient of kinetic friction is 0.37. So we're going to determine the acceleration of the box. All right. So just some important things that we do need to know here for this question, that when we're asking about the acceleration of the box, we're looking for that forward acceleration. And so we're going to have to be working with that forward type of units. So we are going to have a little bit of work here to do. So I'm just going to start off by writing off to the side here our little process, or hopefully what should be going through your head as you start to get comfortable with these types of questions. But I'm just going to write out our process in red here, and then we'll actually do the work in blue here. But so as I mentioned, we're going to be looking for that forward acceleration. So we need to be working with that forward sort of direction. So we have to look at the forward type of force. And so in order to figure out that acceleration, we're going to be using the force is equal to mass times acceleration equation. So we're given our mass right here, but in order to find out this acceleration, we need to know that forward net force. So this one here is where we have to break it down into a few different steps. So in order to find that forward force, we have to figure out what is that net force that's moving forward. So that's going to be equal to your applied force minus any friction or any resistance. So we are given an applied force, but this one here is at an angle. So what we have to figure out is, well, what is this forward force that is acting on the box? So this one here in itself is going to be another step to find. We're also going to have to find our frictional force, which if you guys remember from the previous video, we have to know so your frictional force is equal to your coefficient of friction, or in this case here, we're given the kinetic friction, which is the same thing, and multiply that by our normal force. So then you have to ask yourself, well, hey, are we given that normal force? And the answer to that is no, so we have to calculate that normal force. So we don't have an equation to find the normal force, but what we do know about the normal force is that it's equal to that downward force. And in this case here, that's going to be equal to your gravitational force plus that force that you're pushing down. So I'm just going to put a downward force that you're applying. Okay. We know we can calculate our gravitational force. We have an equation for that one. That one there is equal to your mass times the acceleration due to gravity. And then we can calculate this downward force. That one here, if you guys remember back to Unit 1, we can create a right triangle here and then just find this vertical component here, which I can call x. Okay. Okay, so bear with me. This is going to be a fair number of steps, okay? So what we're going to do is we're going to start with the bottom, and we're going to work our way on up to get to this final step here, which is to find the actual acceleration. So we'll start off over here. We're going to find that force of gravity. And that's just using our force is equal to mass times acceleration equation. So we know from the question our mass here is 49 kilograms. And our acceleration due to gravity, as we know, is 9.81. When you plug that into your calculator, you should get 480.69. I'm also going to keep track of sig figs here. So here our mass here is 49, which has 2 sig figs. And we don't worry about our acceleration due to gravity. That one we accept as a true value. So we only have to worry about our mass here. So our mass has 2 sig figs, so our answer has to have 2 sig figs. And I'm not going to worry about units here until the end of our answer. That's fine. Okay, so step number 2 is we're going to find that downward force that you are applying onto that box. So this one here is going to be, we're finding that vertical component, which is x, and here we have this right triangle that we can use. So here we have a right triangle with an angle, an opposite, and the hypotenuse, which tells us that we're going to find x using the sine ratio. So that sine of theta is equal to your opposite over your hypotenuse. So we'll plug in the information that we know. We know our angle is 20 degrees. The hypotenuse is what we're looking for, and our hypotenuse is 950. To solve this, we can write sine of 20 over 1 and cross multiply to solve. So 1 times x is x. And if you put sine of 20 degrees times 950 in your calculator, you will get 324.92. Once again, we are going to keep track of sig figs here. So here, we're just going to worry about this hypotenuse here, which has 2 sig figs. So our answer will have 2 sig figs as well. Moving on, we can now find this total downward force, which is also equal to your normal force. So I'll call this a big giant step 3 over here. And I'm just going to awkwardly write this over here. So we're going to find that gravitational force, or that total downward force, which is also equal to that normal force. So we'll take this gravitational force plus the downward force that's applied and add them together. So we have 480.69 plus 324.92. When you add the two values together, you should get 805.61 in your calculator. And I'm still keeping track of sig figs here. So in the previous questions we had our sig figs as stated. And so using your adding and subtracting rule, we have 2 digits to the left here, 2 digits to the left. So it'll be in that same position here. So our answer will actually still have 2 sig figs. Now that we have this normal force, now we can find that frictional force. So step number 4. So in order to find that frictional force, that is equal to your coefficient mu times your normal force. So our coefficient of kinetic friction here was 0.37. And we're going to multiply that with our normal force, which we had found to be 805.61. So if we put that into our calculators, we should find that we get 298.08 as our answer there. And then just keeping track of sig figs there. Here we're just going to worry about this normal force. We won't consider our coefficient of friction. So here our answer is just going to have 2 sig figs there as well. So now I need to get more space. So I'm going to erase this. So if you need to, pause the video if you need to write anything down, please. Boink. All right. So now we're going to be moving on to our next step. So now that we have our frictional force, we do need to find that applied force. And so that one there is going to be that forward application of motion here. So now we're actually going to be finding this little y component here. We can call it y, or you can call it whatever letter you want. So this one here is going to be step number 5. Is going to be finding this applied force going in the forward direction. So very similar to what we did for x, we are going to be using the trig ratios to solve and find this horizontal component. And in this case here, we are looking at using the adjacent and the hypotenuse, which is our cosine ratio. All right, so for our value, we had our angle was 20 degrees, and our adjacent was y, and our hypotenuse was 950. We're going to write this over 1 and cross multiply to solve. So here we have that y is equal to cosine of 20 degrees times 950, and that should give us 892.71 on our calculators, and I'm just rounding there. And keeping track of our sig figs, we have 950 has 2 sig figs, so same here, we'll have 2 sig figs as well. Step number 6, now we're going to find that overall net force happening on this. So that's your applied force minus that frictional force. So this will be step 6, or I guess 6 will be right here. So that's going to be the applied force, which we found here was 892.71, and subtract the frictional force, which we had calculated earlier to be 298.08. Plugging that into our calculators, we should find that our answer is 594.63. Just keeping track of our sig figs here. We have 2 digits to the left, 2 digits to the left, which means that our answer is also going to have 2 digits to the left. Now that we have this overall force, we can now find the acceleration. So here we have our force is equal to our mass times acceleration. So our masses we calculate, or our forces we calculated here was 594.63 is equal to your mass, which was 49, times that acceleration. So we want to get acceleration by itself, so we're going to divide both sides by 49. If we plug that into our calculators, we will get 12.14 as our answer there. And then just keep track of sig figs here. Here we had 49 has 2 sig figs in our answer. Here we had 2 sig figs. So using our division rule, our answer will have 2 sig figs. So our answer for acceleration is just 12. I'm running out of time here on this video, so please write a sentence and don't forget your units.